Everyone, welcome to this video. In this video we will be looking at how to do bubble sorting using Java. So for this I have created a class with the name as Bubblesort, and within this class I have written the main program. Now inside this main program, initially I will be declaring an integer array which is having the array elements as 37, 20, 29, 15 and 5 respectively, and this is a single dimensional array that I have considered. Okay, now here, as already mentioned in my previous video, we will use a for loop which will be taking the number of count, or taking the count of the number of rounds which would be required in order to sort these numbers. And after this, what will happen, we will take another loop here, which is, and this loop is used for the comparison of the adjacent pair of numbers, and it will be running to a dot length minus 1. That means if I am having 5 numbers, this loop will be running till 5 minus 1, which is 4. And after that, once this loop is successful, we will be entering into a condition, if condition, where it states that if a of j is greater than a of j plus 1, then here we will swap the numbers which are there in a of j and a of j plus 1. And after this swapping is successful, we will simply display the numbers. Now let us see how this works. First, let us see whether this program is working fine. Okay, so I have saved this. Now let me compile this. Java C, yes, it has no errors. Now let me just execute this. While executing this, we will see that the numbers are arranged in an ascending order and in a logical manner. So 5, 15, 20, 29 and 37, these are the numbers which are arranged in the ascending order as compared to the original array, which was here as 37, 20, 29, 15 and 5 respectively. Now let us see actually what happens here. Okay, so initially when we are considering this array, so first the value of I is equal to 0, and it is comparing this I is comparing a dot length. So what is a dot length? A dot length is 5. Okay, the array length is 5, so 0 is less than 5. So this condition is successful. That means the control will now go to the next loop. Here j is equal to 0, so initially j is declared as 0, then j is compared with a dot length minus 1. So a dot length minus 1 is 4, because 5 minus 4 1, so this condition is also true. So when this condition is true, it will enter into the if condition. So this if condition basically will compare two adjacent numbers, which is a of j and a of j plus 1. So when I am considering a of j is basically first is equal to 0, a of 0, which is 37. Okay, and the next one is a of j plus 1. So a of j plus 1 is 1, the value array index 1, and it has 20. So now if a of j is greater than a of j plus 1, the condition is true here. That means 37 is greater than 20. So this swapping of numbers will take place. That means 37 will be going to the next value. Okay, so the array that we will be getting here is 30, 20, 37, then we have 29, then we have 15, and then we have 5. So after the end of this swapping, that means j is equal to 0, we have evaluated for j equal to 0, we get this particular array. Now in the next iteration, j will be equal to 1, 1 is less than 4. Okay, and again a of 1 now would be having 37, and a of 2 would now be having 29. So 29, again 37 is greater than 29. So now what will happen is these two numbers would be swapped, which will become 29 comma 37. Okay, so again j will now be incremented to 2. 2 is again less than 4. A of 2 now will be holding 37 and A of 3 will now be holding 15. Again the condition is true, so 37 will move to 15, will be swapped with 15. Okay, and then j will now be 3. 3 is again less than 4. Okay, so A of 3 is now 37. A of 4 will now be 5. So the condition is true. So 5 and 37 would be interchanged, which is this condition. So the next condition, when j becomes 4, this condition will not be true. So this condition will not be true. So it will come out of this particular loop, and now it will go to the previous loop. So now I will be incremented to 1. 1 is again less than 5. So again this particular loop will start executing from 0. Again 0 is less than 4. So A of 0 will now be holding. So for this output will, sorry, yes, I forgot. Okay, so A of 0 will now be 20 and A of 1 will now be 29. So is this condition true? A of j is not greater than A of j plus 1. So swapping is not required. J will now be incremented to 1. It will come out and j will be incremented to 1. And 1 is less than 4. So now A of 1 becomes 29 and A of 2 becomes 15. So this condition again holds true. So the swapping will occur here. So 15 will come here and 29 will be swapped. So this way it will go on swapping again and again until all the numbers are properly sorted, and finally we get the output as shown in this particular list. Okay, we are introducing this temp variable in order to facilitate this swapping using a temporary variable. Now what happens is, every time when we are sorting these numbers, okay, so the first, after we swapped the numbers in the first round, okay, when I was equal to 0, so we got the numbers as 15, then it was 29, yes, it was 29, and then it was 20, and we had did we miss out on any one number? Yes, there is another number which is 15. Okay, and 20, yes, 20 is here, 29 is here, so 20 will not be here again. Okay, so these are the 5 numbers. Okay, so when after the end of round 1, okay, so after the end of round 1, what we got was the highest number was placed in the last position. Okay, so whenever we see that the highest number is placed in the last position, that means in the second iteration we do not have to check till the last position, right? We already know that after round 1, after the sorting, first sorting is done, the highest number or the lowest number will be placed in the last position. So we do not need to check this particular position. In order to facilitate faster execution, so if you consider this particular example, it just has 5 numbers, but what if it would have thousands of numbers here? So it would have taken a lot of time, because every time the entire array would have to be searched, or every entire array would have to be array elements need to be compared every time till the last element. Okay, Now in order to cut short the time or make it more time efficient, we can introduce one more condition here, which is minus I. And whenever we are introducing this minus I, every time the check will be done after removing the ith position. That means in the first round, it will be, the array will be searched till A4, okay, till A4, which is already which should have been done in the next round. When I is incremented to 1, okay, the array would be searched till third position, sorted till third position, and in the next round the array will be sorted, or the entire comparison would be done till the second position, and so on. So when we are introducing this particular condition, nothing changes, but the search time of the or the sorting time will be reduced. If we look into this particular code, okay, if I am saving this code and I am executing this, there will be not much change, or there will be no change absolutely to the output that we will be getting. But essentially this change could be reflected well when we are working with very big numbers. Okay, so this is one condition that we can remember. The other condition is that if we want, sometimes what happens that the number of rounds are left, but the array is sorted in a very early stage. So in that case, we do not need to sort the entire array again and again, or we do not need to compare the adjacent numbers again and again. So for that, we will introduce a flag variable here, so which will be initialized to 0. And here, if the numbers need swapping, then we will say that the flag is equal to 1. As soon as the flag is equal to 0, so as soon as the flag will be equal to 0, so let us consider this statement here. So if flag is equal to 0, then we will simply break out of this particular loop. Okay, we will simply break out of this particular loop. So this is seen if the array is sorted in a very early manner. We will not see any much difference here, but if it is a very large number, or if it is having an array which is sorted long time before the number of rounds needs to be completed, we do not need to go ahead with completing of the rounds, but simply introduce a flag variable where if the numbers need sorting, the flag will be 1, and if the numbers do not need sorting anymore, then the control will come out and it will say that it will see if the flag variable is 0. If the flag variable is 0, it will simply come out of the loop. Okay, so this is how basically the things work. Okay, and it will basically make things more faster. All right, now talking about integer arrays. Now if we are talking about, let's say, array, so let's say the string array, I'll give the declaration as string. So here I will be adding, let's say, A, B, C, A, B, C is one string, P, Q, R is another string, and let's say T, U, V is another string. So in order to compare this string, we do not have to do much. We simply have to the similar things only will follow here. We simply have to use a method here which is which is compare to. Okay, so if we are using that particular method, it will become easier for us to solve it. Okay, now if, let's say, how we will make this change, we will make this change as A of J dot compare to. Okay, so a of j plus 1, a of j plus 1, so sorry, a of j plus 1. So if this particular value is greater than 0, then we should swap the strings, otherwise we should not. Okay, so let us compile this and check if we are getting the output. Oh, okay, so unclosed character literal, so this is how your strings should be represented. Okay, so here now it should not be throwing me any error. All right, so what is the error? In string cannot be converted into integer where we have used temporary. Okay, so here also I will use a string. Okay, so yes, now I'm getting the output as ABC, PQR and TUV. Okay, so this is, suppose I give let's say here I am putting as Z, so this should be in the last position. So let us check Java C. Yes, so ABC, TUV and ZQR. So this is how my string would be printed. Okay, so this is all about how we can do bubble sorting using Java. We will talk more about sorting algorithms in my next video. Thank you.